In this video, we're looking at the example problem. A person yells into a cave where the air temperature is 10 degrees Celsius. An echo is heard 0.15 seconds later. What is the distance between the mouth of the cave and the wall in the cave the sound bounces off of? Alright, so we have a time and we want to find a distance. And the link between time and distance is velocity. So if we can figure out what velocity the sound wave is traveling at, we can use velocity equals distance over time in order to solve for the distance. Since we're given a temperature, we can't assume the 344 meters per second. We need to use our equation velocity equals 331 meters per second times the square root of temperature divided by 273 K. So I've converted the Celsius into Kelvin by adding 273 degrees, so I'm plugging in 283 degrees Kelvin, and that gives me a speed of 337 meters per second. Now, remember, we're dealing with an echo. This means the sound wave is starting at an initial position, it's going to the wall and bouncing and coming back. Since we want to know specifically the distance between the mouth of the cave and the wall, we actually want to know the distance to cover half of this time, really. So that's why I plugged in 2 times d here, because the time we're discussing is there and back, not just there. So I'm taking and multiplying the distance times 2 because the distance of interest is covered twice in the time provided in the problem. So I'm plugging in my 337 meters per second equals 2 times the distance we're looking for divided by the 0.15 seconds, and that gives me a distance of 25.3 meters.